Okay, ladies and gentlemen, we are going to look at section 5.1, day 2, and we're going to just talk about general form, vertex form, and factored form of quadratic equations. So just to review, general form, or also standard form, is y equals ax squared plus bx plus c. So just remembering, you write the variable x squared, and then x, and then you put your constant. A review of vertex form is y equals a times x minus h squared plus k. Again, a is our vertical stretch or dilation, h is our horizontal translation, and k is our vertical translation. And then for factored form, we would say y equals a times x minus r1 times x minus r2. So in looking at this first translation, it says write an equation for the quadratic picture below. From the graph, the vertex is 2, 0. Which tells me in vertex form, if we have y equals a times x minus h squared plus k, we know that h equals 2 and k equals 0. And then we also know, in looking at the picture, that there is no vertical stretch, because as we move over 1, we move up 1, or moving over 2 moves us up 4, so a is equal to 1. So as I substitute those values into the equation, we would get y equals, if a is 1, I can just 1 times x minus h. I can just not write the a. So x minus, substituting h, that would give me 2 squared plus k would be 0, so I can leave that off. In looking at number 2, we have the equation of a quadratic whose graph has a vertex at -2, 3. So I'm just going to write down, that tells me h equals -2, and that k is equal to 3. And then we have an xy point. So x equals -1 and y equals 1. So what I'm going to do is write down the vertex form. So y equals a times x minus h squared plus k. And I'm going to substitute in h, k, x, and y and solve for a, my vertical stretch or dilation. So I have 1 equals a times x is -1 minus h is -2. So when I minus a negative, I'm going to plus 2. And then squared, and then plus k is 3. So in doing that work, 1 equals -1 plus 2 is 1. So I have a equals 1 times 1 squared, and then plus 3. 1 squared is just 1, so 1 times a will just give me a. So 1 equals a plus 3. Subtracting 3 gives me -2 equals a. So now, for my last part, I need to substitute a, h, and k into the equation. So you would get y equals, a is -2, so -2 times x minus h is -2, so x plus 2, and then squared, and then plus k would be plus 3. In looking at this problem, we have to write an equation for the quadratic picture below. From the graph, the x-intercepts are x equals 1, and then I look over here, that's 2, 3, and x equals 4, which tells me In factored form, R1 is 1 and R2 is 4. We also notice from the graph, I have an X and a Y point. So I'm going to write that down. X equals 2 and Y equals -6. Now what I'm going to do is write down factored form. So Y equals A times X minus R1 times X minus R2. And then I'm going to substitute Y, X, R1, X, and R2 and solve for A. So -6 equals A times 2 minus -6. So 2 plus, oh, I'm sorry, X is 2 and then minus 1 because R1, I almost substituted wrong. And then X again is 2 minus R2 is 4. So substituting that, I have -6 equals A times 2 minus 1 is 1. And then 2 minus 4 is -2. Multiplying 1 times -2, I get -2. And then I'm going to bring that out to the front. So on the right side of the equation, I have -2A equals -6. And then to get A by itself, divide by -2, divide by -2, and we get A equals 3. So now to get the general form of factored form, we would write Y equals 3 parentheses X minus R1 is 1, and then times X minus R2 is 4. In looking at number 4, we have to write an equation of a quadratic function that has x-intercepts. So x equals -2 and x equals 1, which tells me R1 equals -2 and R2 equals 1. And then we also know that it goes through the point -1, -4. So we know x equals -1 and y equals -4. Now the easiest way to do this is using factored form. So we would just write y is equal to a times x minus r1 times x minus r2. So substituting, y is -4 equals a times x is -1 minus r1 is -2. So minus a negative is going to be +2. And then x here is -1, and then minus r2 is -1. Simplifying, I have -4 equals a times -1 plus 2 is 1. -1 minus 1 is -2. So I notice I need to simplify in the right. 1 times -2 is -2, and I'm going to bring the coefficient to the front. So we have -4 equals -2a. Dividing by -2, we get a is equal to 2. So now, for our final step, we're going to substitute 2, R1 and R2 back into the equation to get factored form. So we have y equals 2 times x minus -2, so +2. So then times x minus 1. In looking at question 5, we're asked to write a quadratic equation that has been moved left 4. So I'm going to write that down, left 4, and then it moves up 6, and then we have a stretch of 12. In doing this, I can see from the information given that I'm going to need vertex form. So y equals a times x minus h squared plus k. In looking that my graph went left 4, I can see that h is going to be -4. And I can see if I move up 6 that k is going to be 6. And then if my stretch is 12, a is going to be 12. So let me just draw a line to separate those. In putting those in, I can see that y equals 12 times x. If I minus -4, I'm going to plus 4. Don't forget the squared. And then I add 6. For question 6, we have to write the equation of a quadratic function that has been moved down to and has a shrink of 16/19. So since it has a shrink and has been moved down, I can see that I'm going to use vertex form. So y equals a times x minus h squared plus k. In writing down the information that I know, if we have a shrink of 16/19, we know that a equals 16/19. It doesn't say anything about moving left or right, so we can assume that h equals 0. And then it has been moved down to, so k equals -2. So in substituting in our values, we have y is equal to 16/19 times, if I put x minus 0, I can just put x squared, no need for parentheses if I'm doing that. And then plus -2, I can put -2.